So this is the 7.2b lecture on volumes of solids of revolution, and today we're going to actually study how we get a solid formed by rotating a planar region about the y-axis, okay, instead of the x-axis. So let me just go review quickly what happens on the x-axis part, and then we'll kind of extend the results to the y-axis methodology. Okay. So here was an example that I did for 7.2a, rotating a region about the x-axis. And if we go and take a look at what actually goes on there, then here's a picture that we dealt with in 7.2a. And so in that case, the solid formed was by rotating this yellow region about the x-axis. And notice how the x-axis is the axis of rotation, the representative rectangle, and similarly the volume that's being generated by the rectangle. The rectangle is going to be at right angles to the x-axis. Okay, at right angles to the x-axis. And what we did was we formulated the volume of a disk, and then just integrated that stuff. So it's pretty much the same sort of thing that we're going to do, except you're going to do it about the y-axis. So here's the example that I'm going to work on. Okay. And again, this is using the disk method. Okay. So what we're doing is we're rotating the region or the area between the curve fx equals x squared, y equals 1, and the y-axis in the first quadrant. Okay. So let's just go take a look at the diagram on that. And this is what the diagram is. Okay, so what we're doing is we are rotating this yellow region, okay, about the y-axis. Okay, about the y-axis. So as you can see, the representative rectangle, okay, is at right angles to the y-axis. It's at right angles to the y-axis. So let's just work on this one. Okay, and so what we have is the disk that's going to be generated by rotating this green region about the y-axis, okay, like so. Its radius is going to be x, okay, as you can see. So for example, at this point here, okay, this distance here is x, okay, and the height of the disk is going to be y. So we know from previous experience that our volume for the disk is going to be pi r squared h, okay, and r is x, so it will be x squared, and h is delta y, or dy, okay. Then all we need to do is put an integration on this, and then we are kind of done, okay. So remember, notice that we're going to integrate with respect to y. Well, what we have here is an x, so we can't quite do that. So we have to come back to our original equation, and we know that that's equal to y. Okay, so our volume is going to be equal to pi, okay, y dy, and our limits of integration are going to go from y equals 0 to y equals 1. Okay, from 0 to 1, and you just do it then. Okay, so you get pi y squared over 2, and you put in 1 and 0, okay, and your answer is pi over 2 cubic units, okay, whatever the units happen to be. All right, so pretty simple stuff, pretty similar to what we did on the x-axis. I chose a pretty simple curve. All right, so I'm going to pause here and see if I can choose another example too. All right, so I spent a few minutes working this problem out, and so I'm going to do number 22 on page 463. Okay, so let me go snip this guy. Okay, and the function is xy equals 6, and you're rotating this yellow region that is between the line y equals 6, y equals 2, x equals 6. Okay, so the yellow region is going to be rotated about this line y equals 6. Okay, And so you're going to get a funky solid there. All right, so how do we do this? Well, since our axis of rotation is vertical, okay, our representative rectangle is going to be at right angles to it. So let me just do the representative rectangle there. And so it's going to be, say something like this. Okay, so this is my representative rectangle. And so imagine this region here rotating about this axis. It's going to generate a thin disk whose radius is going to be this distance here, r. Okay, and if you take a look at that distance is going to be so actually it's not that r, it's really with regard to that point there. So let me go erase that, get another color in here. Okay, I got blue. So really the distance is really from this point here to there. That's r. Okay, that's r. And if you take a look at this point here, this distance here is x. Okay, and this distance here is 6. So then r is going to be equal to, where do I work? I'm going to work out here. So r is equal to 6 minus x. Okay, and the height of that disk is going to be delta y or dy. Okay, so my disk volume is going to be equal to pi 6 minus x quantity squared delta y. Okay, and what I need to do is integrate this. So notice I have an x here and now a y here. I'm going to be integrating with respect to y, so I better get x in terms of y out of there. So I know that x is equal to 6 over y. Okay, and so now my actual volume that I want is going to be pi 6 minus 6 over y quantity squared dy, and the limits of my integration are going to be from y equals 2 from there to there. Okay, y is equal to 2 to 6, and just do it. So getting more space out here, I'm going to get v equals pi integral 2 to 6. I'm going to get the 6 out of there, so that'll become a 36. Okay, it'll become a 36. So my volume is equal to 36 pi. Then I got 1 minus 1 over y quantity squared, and I'll FOIL that. Okay, so I get 1 minus 2 over y plus 1 over y squared dy. Okay, and integrating this is pretty straightforward, which is 36 pi. I'm going to get y minus 2 ln xy minus 1 over y from 6 to 2. Plug and chug, you get 36 pi 2 minus 2 ln 2 minus a half. Put in the, oops, what did I do? I need to put a 6 in there, my bad. 6 in there, a 6 in there, and a 6 in there, minus putting in the 2. I will get minus a 2 plus a 2 ln 2 plus a half. Okay, notice I've already taken the minus sign into account all the way there. Okay, so then this gives me 36 pi and 4, and combining this and this gives me 2 to the 2 ln 1/3 using properties of logs, minus 1/6 plus a half, so that's 3. So that's going to be plus a third, which gives me 36 pi, okay, and 4 and a third is 13 over 3, plus 2 ln 1/3, okay, and I go put this on my calculator and see what we get. And so I have 36 pi times parenthesis 13 divided by 3 plus 2 ln 1 divided by 3. Oops. 1 divided by 3. Now let's make sure I've got this right. 36 pi 13 over 3 plus 2 ln 1 divided by 3. And my answer is 241.588 blah blah blah. Okay, cubic units. Take a look at the answer, see what we have. 241.59, 241.582. Okay, so right there. So this was volume of a solid of revolution obtained by rotating something about the y-axis or some other vertical axis. Okay, all right, so this is the end of 7.2b, and the next one is going to be 7.2c.